Ever wondered how AI transforms a simple text prompt like a cat into a detailed image? It's mind-blowing, right? But here's the catch. What if that same AI could be tricked into drawing a statue when you ask for a cat? Or worse, generating misleading or harmful images without anyone realizing? Let's dive into a groundbreaking study that's redefining our understanding of AI image generation. Researchers are asking a critical question. How do text-to-image models actually learn to connect words with visuals? And more importantly, how could that process be exploited? To grasp this, we need to start with the basics. Text-to-image models, like those powering MidJourney or Stable Diffusion, are trained on vast datasets of images paired with captions. Think of it as teaching a child to draw by showing them pictures and saying, "This is a cat." But here's the twist. Those captions aren't always written by humans. Many models use vision language models, VLM, AI systems that automatically generate captions for images. For example, a VLM might look at a photo of a statue and say, "A marble statue of a lion." But what happens if someone messes with those captions? This is where the research gets really interesting. The team tested 13 popular text-to-image models, from early diffusion models like Stable Diffusion to the latest ones like SANA. They asked, did the models use internet images? Did they rely on VLMs for captions? And if so, were those VLMs public or private? What they found is eye-opening. Most models do use internet images and VLM-generated captions. And here's the kicker. After 2023, nearly all models that disclosed their training methods admitted they used VLMs. The exception, big companies like OpenAI and Google, which built their own private VLMs. Now imagine you're an attacker. Your goal? To mess with the model's training process. How? By injecting fake images into the dataset. But here's the challenge. If the VLM captions your image correctly, it'll overwrite your trickery. So how do you get the VLM to label your image wrong? Enter adversarial perturbations, tiny, almost invisible changes to an image that fool the VLM into generating a false caption. For example, a photo of a cat might get labeled as a spaceship if you tweak its pixels just right. These altered images are then fed into the text-to-image model, teaching it to associate the wrong words with the wrong pictures. The researchers tested this using two massive image datasets, LLaVA and Photo Concept Bucket. They used 3 popular VLMs and 4 diffusion models. Think of these as the AI painters that turn text into images. The goal? To see if maliciously altered captions could poison these models, making them generate wrong or harmful images. But how did they know if the attack worked? Imagine this. A tiny change to a photo, like a few pixels shifted, could make an AI describe a panda as a snow leopard. That's what researchers discovered with a sneaky attack called Adversarial Mislabeling Poisoning, AMP. Here's the twist. These attacks don't just fool AI models, they poison the data they use to learn. Think of it like sneaking bad instructions into a recipe book. The more the AI cooks from it, the worse the dish gets. Vision language models, or VLMs, are the AI systems that turn images into words. They're everywhere, from helping robots see to generating art. But researchers found a loophole. By tweaking images so subtly you'd miss them, attackers can trick VLMs into writing fake captions. These faulty descriptions then get fed into other AI systems, like text-to-image tools, corrupting their training. In experiments, these attacks worked over 74% of the time on models like LLaVA and BLIP-3. Even commercial systems like Microsoft Azure and Google Vertex AI weren't safe. 40% of the time, the AI fell for the trick. And here's the scary part. The poison models created images that were worse than regular bad data, with 73% of attacks succeeding. It's like teaching a kid to draw by showing them a broken crayon. But how do you stop this? Researchers tried blurring images or compressing them, yet the attack still worked 70% of the time. Filtering out suspicious captions only caught 13% of the tricks. Why? Because these attacks are designed to look normal. They're the digital equivalent of a chameleon hiding in plain sight. Now let's flip the script. What if the problem isn't just bad data, but the complexity of the data itself? Researchers found that AI models struggle with verbose images, those packed with text, like crowded infographics or chaotic street scenes. It's like asking a human to read a book written in 10 languages at once. The result? Slower processing and higher energy use. Imagine a self-driving car getting stuck in a maze of street signs. Each sign forces the car to pause, recompute, and use more energy. Similarly, verbose images overwhelm AI systems, causing delays and inefficiencies. This isn't just a technical hurdle. It's a critical challenge for real-world applications like autonomous vehicles or medical imaging. This research reveals a dual threat: adversarial attacks that corrupt training data and complexity that strains model performance. The takeaway: as AI becomes more powerful, it's also more vulnerable. But understanding these risks is the first step toward building safer, more reliable systems. So next time you see an AI-generated image, remember, it's not just about what the model sees, but how it's been taught to see it. And in a world where AI shapes our reality, that's a story worth knowing.